and today I'm gonna present you the first phase of my project, that is Kraken Code. It's a CLI-based coding agent, just like Claude Code, but it is written from scratch in Python by me. I have been really curious on how Cloud Code works, how it is able to edit files, create them, read, run commands, connect to MCP, and do its magic. So I always wanted to create something as cool as it. So today I'm gonna do the first phase of it, and that is connecting my uh, to my large language model via both streaming and non-streaming methods. So streaming method, in sense, you can think that when you talk to any large language model like ChatGPT or Gemini, they don't give you the message as a whole. You can see that very smooth UI of how text keep coming in small intervals of time, and it looks really good. So this is called streaming. Whereas when you wait for 14 seconds or some amount of time and then you receive the whole answer at once, that is called non-streaming. And you can see this in Notebook LM. If you use that, it's a really good tool. You should use that. So today I'm going to talk about all there's two specific parts of streaming and non-streaming that I did. So first of all is our entry function, that is the main.py file. Here I have created my this class called LLM client class. So I'm going to answer two things in this video. First is why I did what I did, because I think why, answering the why is the most important thing a person should do. And then second, the intuition, which may be really correlated with the why. That is the first point, but it's really important. So let's get started. So here I create in my main function. Now you can see that I use this async keyword here. It's because, of course, man, it whole process is going asynchronously. We don't want something as heavy as that to be synchronous and block my input output or channels or other processing. So we are using asynchronous. Let's get into this client class. So why do we even need that, this class? It's to establish connection with our large language model, close that connection, and in case and connection has already been established, so it prevents us from creating new connections and then talk to our LLM. So all the functions that are related to my large language model are going to be encompassed in this class. Now here's my constructor that I created. We have three variables here: the client, the next retries, and the model. Now you can see how I have written them. It's written in underscore client fashion. So what does it mean? It means that to signify that this client, this next retries, and this model, these three variables are my private variables. But it's just for convention. That means Python does not enforce that a client cannot be accessed out of this class. It can be accessed, but it is for programmers like me and you that to tell you in a convention way that, hey, don't touch this variables or don't call them from outside the class. All right. So my client would be my async OpenAI. So we are using OpenAI software development kit, that is SDK. We are not writing our own code because OpenAI SDK allows us to call any large language model by just changing the base URL of that. I have attached the link for that. You can read the documentation. I'm going to open that also. And then max retries, we have gone for three max retries. And the model, we are going with Mistral right now. For our LLMs, we are using OpenRouter because first of all, it's free. That's one of the major reasons that we are using it. And second, we don't want in our one CLI IDE that to only offer one or two large language models. We want it to offer multitude of models so that we can choose. That's what happens in Claude Code or any other IDE, right? So for that, we need to use a specific service that offers multitudes of models. And OpenRouter is really good for this particular purpose. Their inference is also very fast and they have really good SDK. So I directly took them and I mean working on it. So we imported both our this from OpenAI. We imported our async OpenAI, which is gonna be our client. So we type hinted here, and by default it's gonna be none. All right, let's get started now. Our get client function. So it's gonna output an async OpenAI instance. Let's see. So if there is no client, simply create a client. If you are wondering how do I know all this stuff, then I just read the documentation. You can go and read it. It's really easy way to know the questions or the thinking behind how am I doing, what am I doing. Nothing comes out of pure thinking, man. You have to go and read documentation. All right, so then I'm returning an instance of my client. This is for closing the connection. We will first of all check if there a client is present. Then we will use our await keyword. Here await is important. Basically, we use async only when we are using await inside our function. So await symbolizes that hey, stop right. This process is gonna take a little bit of time. So you go and do something else. And in the meantime, run other things. Don't block. Let other function do their stuff. All right, then clear the previous instance that is present. So we have closed the connection and put it as none. So we have updated. Then comes the chat completion. This is gonna actually call the client, that is our open router. So we need three things here, two things here: the messages and the type of stream, whether it's gonna be streaming or non-streaming. For streaming, I went with true, and for non-streaming, I went with false. And my message is gonna be a list of dictionary. Now again, how do I know it's gonna be a list of dictionaries and all that stuff? I think we should go and read our documentation. Here, you can see how my messages are structured and how it's using it. So it's really easy when you know, when you read such stuff, it becomes really easy. So what is gonna output? It's gonna output an async generator. We're gonna come to that. It's a really good thing, man. Stream event common. We'll come to it. It's not. So let's establish a client by calling our client. What are quarks? Quarks are our keyword arguments that we are passing with our client, like the model, the messages, and the stream. All this stuff that we have here is our quarks. Here you can see the model and all that. So instead of writing it separately, we just wrote stuff by ourselves in a dictionary, which is better for us. Now we are going into a for loop. Why for loop? In case an error happens, because error can happen, man. We need to prepare on our side, our end as a developer to perform graceful error handling. That in case an error occurs, it should retry. But till when it should retry, we are going to decide that range. So for now, we are taking only three retries. And because range does not include the last variable, I wrote +1 here. So we have encapsulated in try except block in case an error happens. So if streams happen, that means if it is streaming to a set, if stream set is true, then we are going to go with call this function stream response. Again, it's a private function, but is callable. But by convention, we don't recommend calling it. That's the convention that we follow throughout the code. All right. So stream response, we are passing two things, clients and our quarks, and then yielding the event. So while making this thing, I was quite confused about how coroutine and yield is different from one another. Because I recently worked around with JavaScript and I got to know about this concept of promises, that JavaScript returns a promise when it has to await, and a promise can have three stages like pending, success, or failure. So similarly, both there are a concept of coroutine in Python, that Python has three things: uh, pending, success, and failure. Similarly, as coroutine or event manager for asynchronous tasks in Python. But what is that yield? That was I was particularly confused about. So I studied and got to know that what yield tells is, let's say the yield has been called from this place. So it goes from this to this. It gets one argument, it passes it on, and now the processes that are below it starts running. But this thing, this connection that it has, this path it has established, it keeps on alive so that now it can send more stuff here. So this way, yield sends a generator instead of a coroutine. And a generator is type of that it tells that the data will keep coming on after some time or after any particular interval of time. Data will keep coming on. You have to read that data again and again as the new data comes in and show it. And that's what our async generator is for. As I said, this async generator. That's what it was for. So I think I have explained in a really good manner what the yield and async for is. And here you can see that we are iterating over it only, that we are yielding this event to our main.py, and here we are printing all those messages. See, I'm calling my chat completion here and printing the event as the event arrives. And inside it, I'm calling stream responses. So stream responses also gives out an async generator. So I'm iterating over that generator, and above it, I'm also iterating over this generator that it is passing. So there is recursion here, nesting you can say. And this is similar for non-streaming. Now we don't really need an async generator for non-streaming because it's just gonna output at once the whole thing. But to keep things standardized and concise, which is what production-grade projects are all about, that need code is all about, that you should modularize and centralize things so that there is a proper standardized API to calls. So that's why we told for architecture uniformity, keeping things consistent. Then in case error happens like rate limiting error, so we want to retry. So it's just the retry logic that we use. We are doing exponential backup here. That means on first error, wait for 1 second. On second error, wait for 2 seconds. On third error, wait for 4 seconds. And in case you increase the maximum error, it should exponential the amount of time it should wait should exponentially increase because this connection with large language models are such that sometimes some rate limiting can be happen. Sometimes there's some problem in API connection. So you need to be aware of all this stuff. So we are gonna wait, we are gonna sleep for that a particular amount of time delay, and then we are gonna yield. Now, what is this stream event? We will come to it. Don't worry. Then for API connection error, and for API error, I just didn't wanted to wait because it just signifies that some shit is really gone wrong. So there is no sensi sensibility in retrying. All right, so now we are gonna come to stream response. So as I said, it's getting past the client and the quarks, and it's they're giving out a nursing generator and stream event. Now, when you think about it logically, when you ask something from the large language model, then you are let me just check if it's recording or not. Recording on this computer, yeah. I got a little bit scared. Don't know possibly it's gonna edit or not, but let's see. So yeah, here we were. So what is this stream event? So the logic behind it is like this that we know the output is gonna come in some particular format from the API that we are calling. It's open router. So how should I know or I should I make sure that in future when I change my model or change my provider, I don't need to rewrite the logic again because this logic or this structure that I'm currently getting, it's not a guarantee that it is gonna be standardized throughout the whole industry. So I don't want it to be model dependent. I want it to be agnostic. And that is what led me to this thinking and creating data structures for storing the output that I receive from large language models. So stream event is a class that I created, which would have five things: the type, the text. Text delta is just the chunks that you are receiving in streaming mode. And in non-streaming mode, the entire text. That is what text and delta. Delta is the missing part. That means it is only a chunk. All right, so I have also written that the intuition that why we are created the streaming event, that's what just I shared with you. Because LLMs are auto-regressive. Auto-regressive means they produce one chunk at a time. As we know that they are just next token predicting machines. So for that particular purpose, we did that. So text delta is the text delta which will store my text. Then type, what type of event is it? Is it a missing or only a chunk? Is it a complete message? Is it an error? What type of it is so that I can show it clearly in my UI. Then an error, if there is an error message. Finish reason, Finish region and usage. These two things are for knowing that if everything completed. This finish region is not going to be that important right now, and usage is important so that I can know how much tokens are being spent. Now, how did I myself came to know to structure things like this? Which should be a question that should come into your mind, right? Like, how am I knowing all this stuff? And the answer to it is because I have this structure. This I have this example structure, and how did I got this structure? It's simply I called OpenRouter API once, got this structure as an output, and I deconstructed this or reverse engineered this complete output that I got. So if you can see clearly, the output that I got from OpenRouter is a chat completion object. Inside it, I have ID, I have a choices object, choices list, which has a choice object, then all the metadata and stuff. Then I have a usage in which I have a completion usage object, the provider. All right. And inside this, I have this all the details, how much tokens and all that stuff that got used. And in my choices, I have a variable called message, which has chat completion message, inside which I have content where my actual message is present. So do you see, based on this structure, I reverse engineered how I want my output to be like. And this is what led to me creating such structure like text delta, type, error, finish region, and usage. And next, of course, I'm going to add stuff like tool calling, tools called, and all that stuff. But yeah, and for that purpose only, the default value for text delta is none because sometimes it can happen that it called tool and there was no output for text. So it should manage that stuff also, right? Now, what are event type, text delta, and token usage classes? Same intuition. Token usage, I wanted these four values for myself. Do note that all of these are data classes. So now what are data classes? Isn't that a good question? So it's just a decorator that we use when we want out of the box functions. We don't want to write the constructor, the equality methods, all of that stuff by ourselves. So we simply use a data class, which gives all these things us out of the box when we know that we want to create this class for storing data. That's it. So we have this add method. It's just for overriding how addition between two objects should work. If there is one object of token usage class and then another of token usage and I add them, then how should it work? And why would we be using that? So that we can continuously stack up the token usage. Because if I called once, it would return a token usage object. Then second time I called, it would give me a second token usage object. Then I, for finding the total tokens, I would need to add both of them because each API call is an independent or how should I say it, a custom instance, right? It's a singleton thing. So I need to stack them up in a list and add them all up. So that's what's happening here. I just override this method, add, not override, I wish I created. Yeah, so completion self dot completion tokens plus other dot completion tokens. Self is itself the first token usage class object, and the other is the second token usage object. So we are adding all this stuff. Then is the event type. It's the label that tells the system exactly what kind of event is happening. As I said, whether the text is arriving, the text delta, the message is completed, or an error happened. So we are just using a string enum. String enum is just uh, a way of telling it that it's gonna be a dictionary, but I'm not. I'm gonna write it like variables. So you have to just make sure that the variable which is of event type should be one of these values. It's a way of data validation because like we use find and take. So instead of that, we just use a string enum, str enum, because our output is gonna be in string. Yeah, you can see this text delta, message complete, and error, and they are all string. That's why you use string enum. It tells that that variable value should be one of these three. That's it, not much. And then our text delta class. And I'm using a bottom up approach, but I think it should all be easily explainable, man. All right. And one thing that I do wanna share here that we used this token usage class inside token usage. So how can you use the class without even creating it? So if it was before Python 3.9, I'm guessing this. All right, I'm not sure. So if it was before 3.9, you have to write inverted commas here. But since after that, we can just simply use this from underscore future, import annotations. Then we can use all this stuff, as I said. Then our text data class, it would have only one thing, one variable content. And here we are writing string. So what is this string? It's a magic method, or you can also call it a dunder method. We want simply when we print a text delta, we want the actual string, not the text delta object. If I show you this, I think I have done this, as you can see here. So when I without overriding the string method, if I do this, I will get an object, text delta object. But if I write this string object and tell it to return self.content, then I would have an actual content when I print it. It is especially easy when, as you can see in van.py, I'm direct printing this stuff. But here we are getting stream event only, so I don't think that's gonna make any exception here. So we are done with this file completely. Let's move on. I've explained everything. So now this one specific thing I wanna say. When I tried calling the API, I noticed one thing that the finish region and the token usage I was getting only in the last chunk. This is, I think, an open router specific thing, or maybe it's industry method. I don't know, but I observed this thing that when I'm calling the API, it's not showing tokens and finish region with every message because we are using streaming one. So as the token comes, they don't have the usage info of the finish region. Only the last token has that. So I have to wait till I reach that. So that's what I did. I globally, no, not globally. I declared that in a function at the topmost of the function. Then I wrote response, await chat completion. How do I know this? Simply read the docs. It is written there. This is how you use it. Then I'm iterating for in the response for every chunk. I'm checking if chunk has an attribute called usage, which I again said we only presented the last one. And that chunk dot usage is not null. Simply create a token usage object and fill its value with this chunk.usage.complete tokens. Now, if you can see that in all three of them, I'm using chunk.usage.total tokens. But here I'm using chunk.usage.from token details.cache tokens. How do I know this? Because simple man, I saw the structure. I know that in usage, this completion tokens, from tokens, and total tokens are directly next to usage. But this cache token is inside from tokens, which is inside usage, and usage is inside chat completion. That's why reading the docs and experimenting is really important. So next, if there are no chunks, then we simply continue. If we didn't receive any chunk, then why are we wasting our time? Next, we find finish reason and we find this delta again by that method that I showed you just now, that where this is present, the choices, here is the choices, and we want the first of this list, the first object that is present at this. So that's why we go for index zero, because there can be multiple messages, but I am only concerned about the first one because each chunk is gonna have only one content. If there are rest of the content, then all those are garbage values. I'm not concerned about them. So I check if delta.content is present, and then I wrap that up in my stream event object that a class that I created, type as text delta. As you can see, it's literal, that only out of this. It can be only text data, completed or error. And then simply wrap the content in text data. So I'll yield it here. And in case this complete for loop is complete, that all chunks are alive, then I simply send a final stream event object which has the message of complete message, usage of all the tokens, and the finished result. Now for this, it's over for the streaming. Now we are going for non-streaming one. So non-streaming, simply same, called got the choices object, finish reason, because it's a single chunk. It's not multiple chunks, so I don't have to iterate here. I just get one whole output. I just need to extract all the required details into my data structures that I created, fill them up, and give myself an output. So that's basically what is happening here. So yeah, that was all from my side. I will show you by running this thing. So here, also do know that we are going this iteration in yield iteration in recursion, that this loop is calling this one, sorry, wrong. It's calling this one, all right. And this one is actually calling this one. So that's why we are using yield. So don't worry about that stuff too much. Let me show you by running it once. Python main.py. Our message is write me a joke about AI and false. So it was gonna be non-streaming one. Let's see, it's gonna take a little bit of time for calling the API and we got our output. As you can see, I got the output is a stream event. That's what I wrote. Then it's a single message. My type would be message completed. Then my text delta. Why did AI break with its girlfriend and all that stuff? Error, finish reason, and the usage. And in case I write it as true here, that means I want a streaming output. Now you will see in a second. See this. See the speed. There's now chunks arrived. It was training. So on a customer experience side, streaming one is really better because they don't have to wait for a long period of time. Small chunks will keep, so they will have keep reading it, and it would be really good for both of them, for us as a developer and for them. So yeah, I think that was all for phase one of the project. I explained about the streaming and non-streaming stuff. How do I know all this? Well, I saw a lot of YouTube videos, read a lot of documentation, and experimented a lot. And more than anything, asked shit ton of questions. So much that you can't even imagine. So that's what I would say. Ask question, ask the why behind things, and you will develop a deeper understanding of things. So that was all from my side. That's what I would say. Thank you. Have a great day ahead.